Okay, so let's begin. So yesterday we completed our first chapter, numbers in numeric system. Don't
Yes,
you
sir.
table?
Sir, we can do
Huh?
it.
What is that? Notice board, huh? Brother?
Sir, we can do
Sure. What? The handwritten stuff. Okay, so come quickly, where I want to begin from? Settle down. Sit down. Okay, so we've completed numbers in numeric system. So today we'll be starting our second chapter, which is four fundamental operations on whole numbers. Okay. Yes, Ragana, you can unmute and tell me. Why did you raise your hand, Ragana? Ragana, unmute and tell me. Yeah. Okay. Later on, for 15 minutes, we'll be clearing all the doubts. Okay. Ragana, later on for 15 minutes, we'll be clearing all the doubts. Then you can ask. Okay. Then you can raise your hand. Yes, Manasvi, you can unmute and tell me. How to convert? Okay. At the end of the 15 minutes, I'll be showing you. Okay.
Sir, Manoj. Sir, Manoj, yes, sir.
Everybody can ask their questions at the end of the class. Huh? We'll be having a 15-minute doubt clearing session. Then you can raise your hand and ask the questions. Okay. So now our second chapter deals with four fundamental operations on whole numbers, isn't it?
Yes, sir.
So what are whole numbers? We know that all the numbers,
Natural number.
all the counting numbers, 1, 2, 3, natural numbers and so on, and also 0, isn't it?
Yes, sir.
So these are whole numbers. These are whole numbers, right? Now what are the fundamental operations? What are the fundamental operations?
Addition, subtraction.
Yeah, addition, subtraction, multiplication, division, isn't it? Now, let us see this. Come in. Now let us see this. First, we'll see something called closure law, isn't it? What is closure law? Closure law means, first of all, closure law holds only for addition and multiplication. Okay. What are our four fundamental operations? Addition, subtraction, multiplication, and division. Now, closure law holds for addition and multiplication only. And what do you mean by closure law? If you perform this addition or multiplication between any two whole numbers, then you will again get a whole number. For example, 3 plus 5, whole number. Whole number plus whole number gives you whole number. Then 0 plus 9. 0 plus 9. 9. Whole number plus whole number gives you whole number. In multiplication, 2 into 4.
8.
Whole number into whole number gives you whole number. 0 into 5. 0. Whole number into whole number gives the whole number. So this is closure law. Means if you do addition or multiplication of any two whole numbers, you will again get a
Whole number.
whole number. Okay. Next, commutative law. What is commutative law? Commutative law means, again this will hold only for addition and multiplication. Plus and into, addition and multiplication. So what is commutative law? If I give you 2 plus 9, if I give you 2 plus 9, this is 11.
11.
And what is 9 plus 2?
11.
11. They are both equal. So 2 plus 9 equal to 9 plus 2. That means if you change the order of the whole numbers, there is still, yeah, the answer will be same. We will get them both as equal only. So this is commutative law, okay? This is commutative law. Okay. Same if I do multiplication. In case of multiplication, suppose 3 into 5. What is 3 into 5?
15.
15. And what is 5 into 3?
15.
15. So both are equal. So it doesn't matter in what order you write, multiplication is also commutative. Okay. Next you have associative law. What is associative law? Associative. You need to associate. Okay. Let us see what is associative law. In associative law, again we'll do addition and multiplication. Okay. If I take 3 plus 2 plus 6, what is the value?
11.
Yes, plus, first we'll do 3 plus 2, 5, isn't it? Does everybody remember BODMAS rule?
Yes, sir.
Yeah, so first the bracket, isn't it? So 3 plus 2 will give me 5 plus 6, it will be 11. Now, if in place of 3 plus 2, if I write it like this, 3 plus 2 plus 6 first.
11.
First here now again we'll do this bracket, 6 plus 2 is 8,
8.
2 plus 6 is 8 and 3 plus 8.
11.
It will be the same answer. That means I can write this 3 plus 2 plus 6 is 3 plus 2 plus 6. So associative law means what? It does not matter which addition you do first, which two numbers you take first. Addition is always associative. The answer will be same. Okay? And in case of multiplication? What will be the case? Suppose if you take 3 into 2 into 5. Why am I taking the same numbers? Suppose I am taking 4 into 5 into 2. So what will be the answer? First 4 into 5 will give you 20.
40.
First 20. 20 into 2 means 40. And if we take 5 into 2 first, what if we take 5 into 2 first? 5 into 2 10 and 4 into 10 gives you 40. Okay. Here also the answer is same. So it does not matter which two numbers you multiply first. The answer will be same, and so in multiplication associative law holds true. Okay. Associative law. After that, distributive law. Is it clear, everyone? Very simple laws. Then distributive law. What is distributive law? With addition and multiplication we will be doing, isn't it? For example, if it's 2 into 3 plus 7, okay, 2 into 3 plus 7, what can we write?
20.
What is the answer actually? First we will do the bracket. Bottommost 7 plus 3 is 10.
28, sir.
20. Now what is distributive law? This thing. Basically this is how we do it, isn't it? This is how we'll be doing it. But in distributive law, we'll be doing it in this way. If it is 2 into 3 plus 7, okay, then first what? First this will be multiplied, 2 into 3. And then we'll again multiply 2 with now this. Who is putting the rest?
आपका वॉइस बहुत कुछ कम सुनाई दे रहा है तो क्यों रोहित आपका वॉइस मेरे पास
ये देखिए
हाँ
म्यूट कर सकते
उसको बोलिए कोई मेरा वॉइस सुनाई दे रहा है बोलिए ना आप
Participants sitting at home, are you able to hear my voice?
वो लोग कम्यूट है अनम्यूट कीजिए
Let's see. Students sitting at home, are you able to hear my voice? Are you able to hear my voice clearly? Okay. Okay. Okay, so we'll see now what is distributive law. One more time, you do this with the desk. I'll make you all sit on the floor. I'm telling them not to. Okay, so we'll see what is distributive law. Okay, this is distributive law. Now, what is this distributive law? If we are given 2 into 3 plus 7, then we can do this. First, this is called distribution of multiplication over addition. First, we will distribute multiplication of 2 with 3 like this, plus we will then distribute multiplication of 2 with 7. That is 2 into 7. Okay. So what will be 2 into 3? 6 plus 2 into 7?
14.
The answer is
20.
same answer, isn't it?
Yes, sir.
So that means this line, this is what the distributive law looks like, this line. If you have any three whole numbers a, b and c, by distributive law I can write a into b plus c equal to a into b plus a into c. Okay, here very simple laws, isn't it? Now what do you mean by identity element? What do you mean by identity element?
So 0 is identity.
What do we mean by identity?
So 0 is the identity element.
Hold on. What do we mean by identity element? Identity element means elements with which you do addition or multiplication will not change your number. What does that mean?
That 0 is for addition and 1 is for multiplication.
Yes, it means that, for example, if you do addition of any number with 0, let us say 13. It is 13.
No, sir.
Who say closer?
Sir, I got multiplication of this brilliant state.
Right, so, if you add any number with 0, the number will not change. It's the same number, isn't it? That is why 0 is called the identity element of addition. Okay? And what is the identity element of multiplication? If you multiply any number with 1, if you multiply any number with 1, any whole number, you will get the same whole number, isn't it?
Yes, sir.
The same whole number. So 1 is the identity element of multiplication. Clear?
Yes, sir.
These are the respective identity elements. What is identity element? Which helps you to maintain your identity, isn't it? 13 will remain 13 plus 0. 15 into 1 will remain 15. Now what are the properties of 0? Everybody knows?
Yes, sir. Yes, sir.
What are the properties of 0? With plus, minus, into and division and power. Let us see the properties of 0. We know any number plus 0 will be the same number 5. Any number, if you subtract 0 from any number, it will be the same number. Isn't it?
Yes, sir.
If you multiply any number with 0, you will get 0.
Yes, sir.
And if you divide any number by 0, you will get 0. But remember one thing, this you cannot do. Okay? This you cannot do. You cannot divide 5 by 0. These are the 4 properties of 0. What are the properties? The properties are that if you add any number with 0, it will be the same number. If you subtract any number from if you subtract 0 from any number, you will get the number itself. If you multiply any number with 0, you will get 0. And if you divide 0 by any number, you will get 0. Okay? But you cannot do this, dividing any number by 0. You can divide 0 by any number. Clear? And what is this? Another property. What is 4 to the power 0? 1. 5 to the power 0? 1. 92 to the power 0? Any whole number to the power 0? 1. Okay? So remember these properties of 0. And what is the property of 1? Just now we saw. You multiply any number with 1, you will get the number itself. Identity element 1. Okay, now do you remember the tests of divisibility?
Yes, sir.
Okay. What are the tests of divisibility? We'll see divisibility. First we'll see for 2. What is the test of divisibility of 2? If the last digit of any number, suppose I take this number, if the last digit of any number is even, if the last digit of any number is what? Or even or 0, isn't it? If this digit, the last digit of this number, if this is even, means 2, 4, 6, 8 or 0, then this number will be divisible by 2. Okay? What about 3? 3 means what? If the sum of the digits of your number is divisible by 3, then your entire number will be divisible by 3. For example, 1, 4, 2, 2. If I take the number 1422, find out the sum of the digits. What is the sum of the digits? 1 plus 4 plus 2 plus 2. This will give you 9. And we know 9 is divisible by 3.
Yes, sir.
9 is divisible by 3
Yes, sir.
because 9 divided by 3 will give us 3.
Yes, sir.
And there will be no remainder.
Yes, sir.
So we can say that this number 1422 is divisible by 3. Okay? Clear? Yes. Okay. Why are you calling sir? Come here. Come. You will space come. What have you come to here? Come. Yes, sir. Come. Come now. Come now. Come. Bring a copy. Bring a copy. You like this so much? Come. Sit here. Okay. So this is that test of divisibility by 3. Sum of this is divisible by 3, then the entire number is divisible by 3. Okay. What is the test of divisibility by 4?
Last two numbers. Last two numbers should be divisible by 4.
Divisibility by 4, what is this? If the last two digits of a number is divisible by 4, then the entire number is divisible by 4. For example, if we take the year 2024, next year,
That is divisible by 6.
the number 2024, look at the last two digits. So 24 here, 24 is divisible by 4 because when you divide 24 by 4, you will get 6. And what is the remainder? 0, isn't it? Okay. So, since 24 is divisible by 4, so your entire number 2024 is divisible by 4. Okay. Next, we'll look for 5, isn't it? 5 is given. Exactly. For 5, it is very simple. For 5, you need to see if in the number the last digit is either 0 or 5, isn't it? If it is 0 or 5, participants can ask their questions in the last 15 minutes, okay? So, if we take, suppose this number 2135, is it divisible by 5? Yes, it is divisible by 5 because this last digit is 5. If we take this number 320, can you see the board?
Sir?
Can you see the board?
Yes, sir. I can see. Sir, it is there. Great job.
Okay, so if you take this number 320, is it divisible by 5? Yes, because the last digit is 0. And 0 is, since it is last digit 0, it is divisible by 5. So remember, the last digit should be either 5 or, then the entire number will be divisible by 5. Next, divisibility by 6. Now, when is a number divisible by 6?
Because it's not divisible by 2.
Exactly. For 6, a number, can you see the board? Or you can put, huh?
I can see.
You can see it. Get up. Okay, so for divisibility by 6, anyone else wants to be sir? You was calling sir, so I made him sit on the chair. Anybody else wants to say something? What?
Are you not sorry?
Are you going to complain about others or are you going to study?
No, sir, they were laughing.
They were laughing because they don't want to study and don't want to qualify for the exam. Isn't it? Do you want to study?
Yes.
Then you concentrate on the study. Okay. So now, for divisibility by 6, For divisibility by 6. What do you have to see? That whether the number is divisible by both 2 and 3. Okay? It should be divisible by both 2 and 3. For example, if I take the number 216. First of all, check for 2. The last digit is 6, which is even. So the number is divisible by 2. Now check for 3. 2 plus 1 plus 6? 9. Sum of the digits is 9. And 9 is divisible by 3. 9 can be written as 3 into 3. Plus remainder is 0. So 206 is also divisible by 3. So we can say since it is divisible by both 2 and 3, 216. So it is divisible by 6 as well. Okay? What? Now 6 is clear? Everyone? Okay, now divisibility by 8. Now divisibility by 8. No. 7 is not in your level. 7 is a prime number. But 7 is kind of tough, so not in your level. So let us see for 8, okay? How can you check for 8? A quick reminder to all the students sitting at home, if the meeting suddenly ends, quickly join again, okay? So now, how do you check the divisibility by 8? Yes, if you take a number, let us say, if I take this number, what is this number? 23,50,512, isn't it? Or 2,350,512. So to check divisibility by 8, we have to see the last 3 digits. We have to check the last 3 digits of the number. 512 here, isn't it? So let us see, is 512 divisible by 8? Huh? Divided by 8? Divided by 8? 8 6 are 48. Remaining 32. Then 8 4s are 32, isn't it? So 512 is divisible by 8. So you can say your entire number is divisible by 8. Okay?
Yes, sir.
Okay. So 8 is clear? Now, yes, you have 9 also. So what about 9? Huh? 9 is similar to 3, isn't it? 9 equal to 3 into 3 and 9 is similar to 3. See, for 9, if you have any number, say 729. Or suppose this is the number 3,72,924. Participants can ask their questions after 10 minutes, okay? This number, to check divisibility by 9, how can you check? It is similar to 3. How is it similar to 3? Sum of the digits should be divisible by 9. But don't write 3, okay? Sum for 9, for 3 it was sum of the digits should be divisible by 3. For 9, sum of the digits should be divisible by 9. Okay? Gagan? So here what is the sum of the digits? 3, 7, 10, 12, 9, 21 plus 6, 27. So is 27 divisible by 9?
Yes, sir. Yes, sir.
Yes, because 27 we know is 3 into 9, isn't it? So 27 is divisible by 9.
Yes, sir.
So sum of the digits is divisible by 9. So you can say the entire number is divisible by 9. Clear? Now let us quickly check for 10.
The last number should be zero.
For 10, if in a number the last digit is 0, only the last digit, this last digit is 0, then this entire number is divisible by 10. Is this divisible by 10? 523? Is 125 divisible by 10? Is 320 divisible by 10? Yes, because the last digit is 0. Clear? And finally by 11. Finally by 11. In 11, remember it, 11 is a little tricky, remember it. For 11, if you have a number, for 11, that all is a copy or that is a, where is a copy? Yeah? You don't have your copy? Where is it? Why is it closed? You like to write on the wall instead of your copy? So what is the case for 11? What is the case for 11? Huh?
Any number which ends
Remember it? The sum, if the sum of digits in even places, huh? Sum of digits in even places should be equal to sum of digits in even places should be equal to sum of digits in odd places. Okay. Sum of the digits in even places should be equal to sum of the digits in odd places. Then your number is divisible by 11. Let us see this number. Let's say
3462.
what is this number? 32,27,411. So now, which are the digits in the even places and odd places? What do you mean by odd and even digit places? See, this is the first place, isn't it? Just a second. This is the first place. This is the third place. This is the fifth place. This is the seventh place, isn't it? First place, third place, fifth place, and seventh place. Listen very carefully. And this is the second place. This is the second place. This is the fourth place. And this is the sixth place. So all these are your even places of the number, isn't it? Okay. And all these are your odd places, correct? So now, for the number to be divisible by 11, the sum of the digits in odd places should be equal to the sum of the digits in even places, right?
Sir,
Okay. So, for it to be divisible by 11, the sum of the digits in odd places should be equal to sum of the digits in even places. So, what is the sum of the digits in odd places? What is the sum of the digits in odd places? Hmm?
10, sir.
Let us see. The sum of the digits in odd places, huh? Sum in odd places. See? 1, 4, 2, 3, isn't it? It will be 3 plus 2 plus 4 plus 1, right? It is equal to 10. And what is the sum of the digits in even places?
2 plus 7.
Sum in even places?
10.
Sum in even places? 2 plus 7 plus 1. Isn't it? 2 plus 7 plus 1. 20. Gagan. Gagan? You know what is the meaning of Gagan? What is the meaning of Gagan? Sky, isn't it? You want to reach the sky?
Sir, yes, new meeting. Sir, answer question is hard.
I will mute you. Keep quiet, okay? Can you hear me now? Okay. Just give me a minute, huh? Uh, okay, let's continue. So we can see the sum in odd places equal to the sum of the digits in even places.
Yes, sir.
10 and 10 equal.
Yes, sir.
So this given number, what is the given number? 3, 2, 2, 7, 4, 1, 1. This is divisible by 11. This entire number is divisible by 11. Okay. Here. Any doubt in this? Huh? No.
No, sir. Not out, sir.
Sure.
Yes, sir.
Oh.
Sir, we have doubts.
And another thing, you know the units place digit? So, if I ask you, see everyone carefully, if I ask you, what is the unit digit in this multiplication? What is the unit digit in this?
Multiplication.
Let's say 624 into 729 into 31. So what is the unit digit after you multiply them? Unit digit 54. Digit is only 1. So what will be the unit digit after you multiply them? You know what is unit digit? What is unit digit? The digit is the unit digit. So the unit digit after you multiply this will actually, you don't need to multiply the entire thing. To find it out, you can just take the unit digit from each of the number, okay? 4, 9 and 1. Now, unit digit in this is actually equal to unit digit when you multiply only the unit digits of the numbers, that is in 4, 9 and 1. Okay? And what is the unit digit in 4, 9 and 1?
36.
4 into 9 into 1 is what? 36? So what will be the unit digit? 6. Is it clear? Is it clear? Okay. So now we'll be moving into the doubt session. First, let me see someone from the participant if they have any doubt. So sitting at home, Abhay Sanjay Prasad, you can unmute and ask me what's the doubt. Can you hear me now? Yeah, it may be due to bad internet connection. Okay, Abhay. Do you have any doubts regarding the topics? Can you hear it now? Hello, Abhay. Hello. Abhay, can you hear me now? Which one? Abhay, which one? Abhay? Abhay, which one you're saying? Which one? Which topic you want me to repeat? Unit digit.
Yes.
Okay. See, unit digit, unit digit if you want to find in the multiplication of some numbers, if you want to find the unit digit in the multiplication of some numbers, then how you can find that? You can find that by simply taking the unit digit by simply taking the unit digit in the unit digit of those numbers. Basically, I am asking you to find the unit digit in this multiplication. So for that you don't need to do the entire multiplication. You just need to take the unit digits from here, 4, 9 and 1. Okay? 4, 9 and 1. And then you have to find the unit digit in 4 into 9 into 1. What is 4 into 9 into 1? It's 36. So the unit digit is 6. Okay? Yes, Aditi, you can unmute and ask. Now we are having a doubt session. You can ask. Do you have any doubt, Aditi? Sorry about that. It may be due to bad internet connection. Can you hear me now? Aditi, can you hear me now? Okay, then tell me, do you have any doubt? Aditi? Yes, Shloka, tell me, any doubt? Oh, okay. It may be due to bad internet connection, as I said. Anybody who is here, who has put their hand up due to voice breaking, put your hands down, okay? We're having our doubt session now. Shloka, do you have any doubt to clear? Okay. Shloka, any doubt you want to ask? Jeevan, you can unmute and ask if you have any doubt. Yeah, tell me. Okay, now tell me if you have any doubt. Do you have any doubt to ask? Do you have any doubt to ask? Everybody who has put their hand up due to voice breaking, put it down. We're having our doubt session now. Okay, so anyone from the class has any doubt? No doubt. Then I'll start. Let's start asking questions. Yeah, start asking questions. What is 54 into 55? Huh? Where's the copy? Where's the pen? Where's the copy and pen? Why are you getting up? They're telling you to get up. Sit down, one by one. First, we haven't moved on to campus corner. Do you try campus corner before? What happened? Down. Okay, just a minute. Sit down. Sit down. Sit down. Did you eat anything before coming here? Why are you eating your pencil? Okay. So here they have a question. You are saying this is a doubt. 1 0 0 0 0 0 0. This is obtained when a number is subtracted. When some particular number is subtracted. Okay. From the sum of. From the 893645 plus 635489. 489, isn't it? Who asked this doubt? So first do this addition, you can do normal addition. Huh? Where's the pen and pencil? Pencil and paper. Pen, paper, pencil, paper. Copy. You're asking doubt and you don't have your copy outside. So you can do this addition. You'll get here some result. Isn't it? You can do this addition at home. Minus, you need to find this number, isn't it? Let's say this number is x. Okay. This will be equal to this. So now what? Now, how will you find it?
By doing addition.
How do you do it? By subtraction?
Addition.
If I tell you, you get 2. You get 2 by subtracting something from 6. What is this number? 2 equal to 6 minus something. What is this number? 4. How do you get that 4? 6 minus 2? 6 minus 2? Isn't it? 6 minus 2? So look here. So this number also that you have to find. How can you get it? by doing this minus this. Okay. Yeah. You can do it at home. Do the calculations. Okay. Any other doubts? Share the doubt. 28. These questions are written in the next class. Anyone has a doubt regarding anything from the previous class? From the previous chapter? No. From this chapter we will be doing in the next class, okay? Still 28, the number is given, the number 13013 is divisible by 13, isn't it? The smallest 5-digit number beginning with 14 and exactly divisible by 13 is. So, what do we have here? Everyone go to your entrance corner. This chapter, 4 fundamental operations for whole numbers. Go to your entrance corner. Huh? Sorry? Question number 28. क्या हुआ?
डाउट नोट है ना सबका
हाँ तुम देखो करना था
सब चुकी देना
नहीं आएगा कीबोर्ड आपका
इसमें सबसे लास्ट में होगा ना
जस्ट सेकंड नहीं है तब मैं तो नहीं रहती और ये
उसको पूछिए
वो हाथ जस्ट वन मिनट Yeah, Tanmay, I heard you had a doubt. Yes, Tanmay, you can unmute and ask your doubt. Tanmay, yeah, you have a doubt. I heard. So sorry. Tanmay, what are you saying? Which question? Which one? Which one? Just now that I did subtraction one. Okay, subtraction one. This is from your 4 fundamental operations and whole numbers. This chapter only. Okay. And this is question number 7 from the entrance corner. This is question number 7 from the entrance corner. So what is given in the question? If you see in the entrance corner, question number 7, it is given that. It is given what? It is given that you actually have to find some x. Okay. You actually have to find some number here, isn't it? This number you have to find. And if you read the question, it is saying that you obtain this number. You obtain this number, which is 10 lakhs. Just a second, yeah. You obtain this number when you do the addition of these two numbers and you subtract a particular number, and they are asking you to find the value of this number. Okay. So here, after adding these two numbers, you will get something. So here, after adding these two numbers, you will get something here, isn't it? You can do this addition at home. And now you have to subtract this particular question mark number to get this, isn't it? Understood? So now how can you find this? How can you get this question mark? Yeah, tell me. No, we should not add, we should subtract. See, here we have 9 plus 5, 14. Okay, 3, 1, This is the value, okay? So now we have to subtract, isn't it? Why subtract? I'm telling you. Yeah. See, Tanmay, can you hear me? Tanmay, you can unmute and tell me, can you hear me? Yeah, so see, for example, suppose instead of all this you have this, okay? 2 equal to 6 minus something, okay? Suppose the question was this, 2 equal to 6 minus something, clear? So now tell me, what is this question mark here? 6 minus what? What is this? How will you get 2? How will you get 2? How subtracting what from 6 will give you 2? The question looks like this, sir. 2 is this, 6 is this, and this question mark is this, isn't it? So now, in this also, if you want to find 2, how will you find this question mark? What is this question mark? This question mark is actually equal to 6 minus 2. It is equal to 4, isn't it? Did you understand? So similarly here also you will subtract, okay? Yeah, you subtract this minus this. So your question mark will be actually equal to 1529134 minus this 1000000, okay? Okay, so now one other question I have here. This is actually from the entrance corner of the second chapter, isn't it? What is the question? It is from the second chapter. 4 fundamental operations with whole numbers, and it is from the entrance corner, question number 28. Number 13013 is divisible by 13. The number 13013 is divisible by 13. The smallest 5-digit number beginning with 14 and exactly divisible by 13 is. Huh? What? See. What is your name? Huh? Ashiri. You want to ask it in place? Ashiri, huh? Sit. So say, everyone sitting at home, now we are doing your page number 13, 4 fundamental operations on whole numbers chapter, question number 28 from entrance corner. Okay. So the here we are given to find the smallest 5-digit number beginning with 14 and exactly divisible by 13. Isn't it? So now, what do we know? What is the smallest 5-digit number beginning with 14? Isn't it 14,000? The smallest 5-digit number beginning with 14, it is beginning with 14 and then we write 3 zeros. Correct? So now you have to find the smallest 5-digit number beginning with 14, but it should be divisible by 13. Isn't it? So we are writing this. What happened? You want to come and explain? Let me explain first. I know you have done it, you can do it fine. Good, very good. So now beginning with 4, this is the smallest number, isn't it? Or we have to find the smallest which is actually divisible by 13 also. Correct? So, what we will do, just simply write this 5-digit number smallest with 4 and we will divide this actually by 13. Okay? So, what will happen if you divide it by 13?
13 ones are 13.
13 ones are 13.
One remaining. Finishing for 13 ones are 13.
Okay, everybody can do this division?
Yes, sir.
13 6 are. So now see. So from here we can see that our 14,000 is basically what? 13 into this 1076. Fine. Plus the remainder 12. What is our remainder here? Varshini, what is the remainder here? 12. So the remainder is 12. The remainder is 12. So, what is the meaning of remainder 12? What is the meaning of remainder 12? Sit down. The remainder 12 is what? This 14,000 is not divisible by 13. It is clear. For 14,000 to be divisible by 13, the remainder should be 0. Now, when will the remainder become 0? You have to now find the smallest 5-digit number which should be divisible by 13. So remember one thing, if you keep on increasing your remainder, increasing or decreasing your remainder, you can make this remainder 0 by decreasing it to 0, or you can make it 0 by increasing it to 13 itself. Okay? That means what? If you want to make this remainder 0, add something so that you get here 13. Because your divisor is what? 13, isn't it? So, how much should you add to make this 13? You cannot subtract. If you subtract, it won't remain a 5-digit number beginning with 4, isn't it? Because this is the smallest. So, how much should you add? Only 1? Only 1? So, if I add here only 1, if I add only 1, that is 14,000 plus 1, then this number will actually be what? 14,001? This will be divisible by 13. So this is your smallest number, smallest 5-digit number beginning with 4, which is divisible by 13. Okay? Here, you just have to see how much you have to increase or decrease, okay, so that the remainder goes to 0 or it goes to the divisor itself. Clear? Is it clear? Question? Okay. So that will be all for today. Everyone sitting at home, that will be all for today. Okay. This is the end of our class. Take care, study well. Okay, bye bye.